For 30 years, the Defence and Civil Institute of Environmental Medicine was Canada's centre of expertise for defence research and development in human performance and protection, human systems integration, and operational medicine. Renowned worldwide, the Institute supported the air, land, and maritime elements of the Canadian Forces, as well as those of the Surgeon General. DCIEM's roots reach back to 1939, when Sir Frederick Banting recognized the need for specialized research into aviation medicine. Thanks to him, the federal government established the Associate Committee on Aviation Medical Research at the National Research Council, laying the groundwork for decades of scientific innovation. In 1940, the RCAF purchased the Eglinton Hunt Club in Toronto for use as a new aeromedical research facility, the #1 clinical investigation unit. A low-temperature, low-pressure chamber, and the first human centrifuge in the Allied world were both constructed there. Dr. Wilbur Franks used this centrifuge to pioneer and create the world's first anti-G flying suit to go into service. Ottawa then formed the Defence Research Board in 1947 to continue supporting scientific defence research. The board absorbed 7 existing wartime research centres, including Defence Research Establishment Toronto at Downsview. At the same time, #1 Clinical Investigation Unit became the Canadian Forces Institute of Aviation Medicine. It was these two outfits that were amalgamated in 1971 to form DCIEM. Over the next 3 decades, this dynamic new organization combined the expertise of hundreds of civilian scientists and operational military personnel. It was a hotbed of R&D and the only Canadian Defence Research Centre addressing the human-machine interface. DCIEM's research facilities included a human centrifuge, hypobaric chamber, impact test track, environmental chambers, diving research facility, and noise simulation facilities that enabled researchers to simulate the risks inherent in military aviation in a safe and cost-effective environment. Life support equipment for aircrew was a key focus, covering everything from helmets, life vests, and cold water immersion suits to restraint systems, oxygen equipment, G-suits, cooling vests, and active noise reduction technology. A notable innovation was the Sting Anti-G Ensemble. This advanced system introduced positive pressure breathing, which significantly improved pilot endurance under sustained G-forces. DCIEM also excelled in operational research on the effects of fatigue, spatial disorientation, and motion sickness. Equally critical work was done in aviation human factors, including the Institute's comprehensive review of human factors affecting CF-18 pilots, which resulted in 25 specific recommendations for improving flight safety and operational effectiveness. DCIEM also supported tactical and maritime helicopter operations for both the CH-146 Griffin and the Sea King, through detailed human engineering assessments that shaped aircraft life cycle decisions. Another vital part of its mission was training and simulation. An aircraft crew station demonstrator enabled cost-effective virtual cockpit design. Later, advanced simulators were developed to train aircrew in complex missions such as shipboard landings and formation flying. All Canadian Forces fighter pilots were trained in DCIEM's human centrifuge, where they safely experienced high-G environments. Medical personnel, including Canadian Forces flight surgeons and Transport Canada physicians, also received specialized aerospace medicine training at DCIEM. On the medical front, the Central Medical Board, Canada's only full-spectrum clinical aeromedical facility, supported both military and civilian air operations. Its on-site services, staffed by certified professionals, included full cardiac, pulmonary, and vision tests. The board was responsible for Air Force aircrew medical selection, and every pilot candidate underwent in-person detailed assessments before acceptance for training. CMB personnel also provided aeromedical assessments for Transport Canada, Canadian Airlines, and airline pilots associations, allowing certain aviators with serious conditions, such as diabetes, to retain their medical certification. Because of its aeromedical expertise, DCIEM was tasked to provide medical oversight and support to the selection and ongoing medical certification of Canada's astronauts. Between 1983 and 2001, it screened all Canadian astronaut candidates and contributed to their training through high-G and altitude chamber exercises. Its facilities even supported simulated spaceflight isolation experiments, such as the Capsules project, as well as evaluation of protocols for spacewalks using the altitude chamber. Beyond its in-house research, DCIEM collaborated widely with universities, government, and industry. Its scholarly papers, patents, and innovations benefited NATO, international aerospace science, and Canadian companies including Gentex and Canadian Marconi. In 2001, Defence R&D Canada was formed to manage Canada's defence research centres, ending DCIEM's role as an independent institution. Over its 3 decades of operation, DCIEM's productivity and collaborative approach made it a pillar of Canadian excellence in the protection and performance of humans in aviation and aerospace. Its legacy lives on, not only through its accomplishments, but also through global acknowledgement of its contributions to aerospace medicine. For being one of Canada's most significant research establishments and a world leader in innovation related to the protection and performance of humans in aviation and aerospace, the Defence and Civil Institute of Environmental Medicine was presented with Canada's Aviation Hall of Fame's Belt of Orion Award for Excellence in 2025.